So Dr. Harisu holds a PhD degree in artificial intelligence and data analysis and visualization, or we can say in computer engineering and data analysis. He is currently working with the Ministry of Social Welfare in Social Department in New Zealand. And also he's a researcher with the University of Victoria, Victoria University of Wellington, New Zealand. So it is our hope today we are going to tap from the knowledge of Dr. Harris, and he will take 1 hour approximately for his presentation, and then for the other time maybe you allocate 30 minutes or more for questions and answers. So please, Dr. Harisu, the floor is yours.
Thank you, Dr. Jakada, for the introduction. As Dr. Jakada mentioned, that we're going to be having this tutorial on data analysis and visualization. But before I start, I would like to just maybe say a few things. Firstly, I would like to extend my heartfelt gratitude to the Ganji mentors for offering me this opportunity to give this tutorial. It is truly an honor to to present and share the insights on data analysis with you all. And for the purpose of this tutorial, I'll be utilizing the Nigerian 2019 election data. But however, I would like to emphasize that my intention is solely to aid participants or everyone attending this presentation in comprehending whatever we'll be doing today. There is no implication whatsoever kind of like associated with any political party or specific state that might be predominantly featured in whatever we'll be doing here. And it is important to clarify that the use of any political party or state is purely for demonstrative purposes and should not be seen as any underlying sentiment or implications. Yeah, with that said, I think we can dive into the data analysis stuff with you all. And I will be sharing my screen. Yeah. I see my screen now.
Yes, we can see.
Yes, we can see your screen.
Nice. So as I mentioned that we'll be using election data, so I just tried to kind of put some notes on whatever we'll be doing here. Maybe some of them are here, but yeah, if time permits, then we can go and do some other things as well. This is how the data looks like. So you can see the states, geopolitical zones, number of registered voters and stuff, APC votes, PDP votes. So all of the, like there might be some other political parties, but then this is just showing two political parties, APC and PDP. And I'm using Google Collaboratory for this task, and this is an online kind of environment that allows people to use kind of like to program, and you can use Python. I mean, you can use different resources. You're actually using your computer, but then you're not running anything on your computer. You're running it online. So yeah, anyways, yeah, we'll just dive into it. I'll be importing the data here of 2019 election data, and yeah, I've imported it. So we'll be importing the packages to do this. And today I'll be showing like I'll be kind of like going through 4 different packages. That's like pandas, matplotlib, and then there's seaborn package, and then there's plotly, all in Python. But so I'll be going through all of this one by one. So we'll start with pandas package. Maybe I can just comment this. So import pandas. So to import pandas, you say like import pandas in Python. And if I say speedy, this is just like the acronym usually mainly used. So you don't really want to be saying pandas dot all the time. So you just say pd dot instead of saying pandas dot. And here we're saying we're just trying to read our data. We have our data in CSV file, and so we're going to read the data here. If I copy the path, yeah, so I have the data now. So we get an error. What is the error saying? The name reader field is not defined because we did not import this. So we just import pandas. Sorry, yeah. So PD just read the CSV. Yeah, they say because of is it presenting something live, you just be making mistake all the time. Yeah. So where we have we've read the data, and now we're just kind of visualizing the data using Python. You can see this is the data that we've seen here. And you can kind of maybe see the information in this data by using something like data.info. You can visualize the information. So just giving you a rough idea of like what the data looks like. So we have different columns: state, geopolitical zones, number of accredited voters, and so forth. And then this is telling the data type. Some of them are integer, some of them are float, and some of them are objects here. So this one's represented shown as object actually might be string because string objects are shown as objects in Python. I mean in pandas when you're using pandas. So we can describe the data also, saying like something like data.describe here, and then we can see this is like this will show us like kind of like the mean, standard deviation, minimum, maximum, and whatsoever from the data. So now that we have seen what the data looks like, we've seen the columns. So maybe we can start maybe having a look at like different values and the data. So if you look at the columns here, we have a column called state here. So if we copy this, now we want to look at states. If we say df the states, we just put state here, and then we get the list of states. And why are we using df? We use df because we call this we're reading the data. I mean, we define that as df. That's like the short form of data frame. So here now we want to look at like the geopolitical zones in the data. So one good thing with this Google Colab is that it suggests things for you. So I just say df and I put the brackets, but then now it's suggesting the name of the columns for me. So I want to use geopolitical zones, and when I read it, we can see showing the geopolitical zones, but I don't want to see all of them. This is showing like the whole geopolitical zones for the 6 states, but I only want to see the unique geopolitical zones. So if I use this dot unique, we can see the unique geopolitical zones from the data, and we have 6. If I'm not mistaken, and it seems to output 6, so which is correct. Yeah. So now here we want to get the number of registered voters, and to get the number of registered voters, we can define a variable called registered voters equals df. We just open bracket and then it will start suggesting. So what do we want to look at? We know there is something called NR registered voters. Yeah. So this will show us like the number of registered voters, but maybe actually I want to look at the sum here, not maybe total number of registered voters. Right. So if we say here, this will give us the all the registered voters. We can just print this maybe to see how the data looks like. So this is giving us everything, but we want to find the sum. So if you say sum and you put your list, everything in bracket. So if it is like another programming language, you'll probably have to use like a for loop or something like that to kind of loop through everything to find the sum. But in Python, it's pretty easy. You just say sum and then you put the bracket and then you get your value. So we just add sum now to this data printed below. And when we print this, you see, we can see now we're getting the total number of registered voters here. Similarly, let's say we want to find our accredited voters. We can copy these here, we paste it, and then instead of registered, we say accredited, yeah? And then we say here, we also be accredited voters, and our column now should be accredited voters. So accredited voters. I'm not sure if I'm right or wrong, but it will. We'll see. Accredited voters. Yeah. Okay. That's how it is. So accredited voters. We have the total number of accredited voters. So total number of votes cast. Yeah. For vote cast, we can do the same, and we can just see like where the votes cast here, and then here for the votes cast. It's asking me if I'm a robot. Okay. Yeah, votes cast, and then we want to put votes cast here. So here we can see the total number of votes cast there. And yeah, I don't want to be. I wanted to kind of like, well, yeah, maybe we can just put them, but because I feel like they're more or less the same thing. But yeah, we can just go through them. So total number of valid votes, we just say something like valid votes, and then the same thing here. We just copy paste, and then we change this now to what? Valid votes. So we have our total number of valid votes. Similarly, we can do the one for rejected votes. And then we see here we have rejected votes, and then, well, actually we have total number of votes cast, right? and then we have the total number of valid votes. So instead of assessing the data of, let's say, total number of rejected votes, maybe using something like this. This will give us the total number of rejected votes if we say rejected votes, right? But instead of doing this, we can say maybe like rejected votes. We know that the rejected vote should be like the votes cast, yeah, minus valid votes. So this should give us the rejected votes. If we print this, we're having around 1.2 million or 1.3 million, something like that, roughly. And for sanity check, if we just access this data from this using from different, you see we're getting the same thing. So yeah, that looks right, yeah. And then we can check the PDP votes, and then the, I know this bit might be boring because we're just kind of like doing similar stuff and repeating it over and over. But I promise to finish it soon. So yeah, we have, let's say, PDP votes, and then we're printing this, and then we'll send PDP votes. And you can see PDP had something like 11 million or so. And we can see APC votes, we can see the total number, APC votes, and then we see APC. APC had like around 50 million. And this was like this was in 2019, right? Yeah, so now let's say we want to like should I continue? Okay, cool.
Yes, please continue, Dr. Harisu.
Yeah. Okay, so now let's say we want to like if you look at the data, let's say if you look at the data frame, you see we have a lot of columns here. But let's say we don't want all of these columns, we only want few of them. So we can filter the columns in something like filtered column equals, then we put the number of the columns that we want. We can specify like state all the columns here. Let's say political zone, and then we have something like PDP votes, and let's say APC votes. So we only want to keep these columns, and then we get rid of the rest. If you notice this, like some of them, sometimes I might be using double quotation, sometimes I might be using single quotation. It doesn't really make any difference. It's just you can use anyone you want, but just maybe for the sake of like maybe good programming, you might want to keep. Maybe you might want to be consistent. We can just try running this like this, and then we can see what we're gonna get. And then after that, maybe we'll just change it to single quotations. So here, the filtered column, we said like we want to keep only these 4 columns, yeah? So if you run this data, and then here, you see, we drop the rest, we only get this 4. And there's no error. But as I said, for the sake of maybe, just to be consistent, I should say. Maybe you want to just keep this. And maybe if you say head, this will just print the first few few rows rather than everything. So let's see here now. Here was we want to find the total number of APC and PDP votes by geopolitical zone. So we can see votes by geopolitical zone, and then we can just put our data frame. Now we're grouping the data by what? By geopolitical zone, because we want to find the we want to group the data by geopolitical zone, and then find the sum. Yeah. So I don't know if I'm wrong in the spelling, but yeah, we'll see. We will get error if it is wrong. Okay. Yeah, seems like it's right. So you see, it's sure like not central, around 2 million PDP votes and around 2.5 million, about 2.5 million APC votes. Northeast and so. Okay. So this is we just group the data by geopolitical zones. We find the sum of the data by each the sum of PDP and APC votes by geopolitical zones. Here, let's say we want to find total number of APC and PDP votes across the northern, in the northeastern region. So we'll say something like northeast. We want to find the total number of APC and PDP votes only across the northeastern states, but we want to also show these states. If you look at what we have above here, we can see the total number, but we don't want to find the total number across the geopolitical zone. Here we also want to show the states. So if we say something like, and then we find geopolitical zone, and then we say is equals to northeast, yeah. And if we print northeast here, you can see Adamawa, Bauchi, Borno, Gombe, Taraba, and Yobe. And you can see the total number of votes. And all of them are northeast. Yeah. So here we're just going to find, let's say, the sum of let's say everything, mean, median, mean, max, and stuff like that in the data. So you can say this of APC votes is supposed to access our data frame, and we say APC votes, and the list of PDP votes, we access our data frame and we say PDP votes. Yeah. So we have the data now in this list. So to find the sum, we can say print sum, and then we put APC votes. Maybe we can print this. We can say sum of APC votes, and then something like this. Here, let's say we want to find the mean or average PDP votes. Let's say. So we have list, and then we have PDP votes here. So you see, yeah, we have our result here. We can print, and similarly, we can find the mean and max on mean, max I don't know if this is the right way to say, but yeah, doesn't matter. Yeah. So the highest, or maybe and then the lowest votes received by these parties. Okay. Now we can do this this last one, then maybe we can move on to visualization part, because I feel like we've already spent some time here. So this is saying calculate the average percentage of valid votes. So we can see average valid votes is equals to, we assess the valid votes here from the valid votes column. We set the mean, and then we get divided by the registered votes. Do we have registered? Oh yeah, we have registered voters. They multiply by 100, and we can print something like the average valid vote percentage or something like that, and then we can put our variable that we just created above. If we print, so we have an error. Where is the error coming from? We're saying average valid votes. Perhaps you forgot a comma. Yeah. So you see, it said like syntax error, invalid syntax. Perhaps you forgot a comma. There should be a comma after this. So we just still there's an error somewhere. Valid votes. I don't know if it is valid votes. Is it capital V? Not capital V. We say small. I see where. You remember we dropped some columns, yeah? So if you print this, you will see that we have state, geopolitical zone, PDP, APC, but we don't actually have valid votes here because we dropped it. We removed it. So we can just read the data again, maybe. This is not the right way to do it, but yeah. Anyways, we can just say we are reading our data again here. And then we just access, we just run it again. So we have the percentage here. And here we can find the state with the highest number of PDP votes. Let's say max PDP votes, maybe state equals to like and we should get DF, and then we get PDP votes here. PDP votes, and we want to get only the maximum, yeah. And we want to get the state because this we are saying that we want to get the state with the maximum number of PDP votes. And if we print this here, we can see print. And then we put our comma so we don't get another error. And here we can say state with highest number of PDP votes. Highest PDP votes or something like that. And then which state is it? We see it's Kaduna here. Similarly, here we'll say calculate the average APC votes across all states. What's the average APC percent? Apologies for my use of variables. Variable names, I'm not so good with that. I'm just like trying to define something and then it might not make sense. So here we're printing, and then what do we want to print? We're saying average APC, average percentage of APC votes. Yeah. Yeah. So the last one before moving to the visualization, we say like calculate the total number of votes as in the South-South political region. So we are saying South-South votes, and then we want to get the total number of votes cast in the votes cast in the South-South geopolitical regions. So here we're saying geopolitical zones, and then we have to say equals South-South, and we want to get only the votes cast and the sum. And if we print total votes cast in South-South, and then you can see that we're getting that as well. Okay, now maybe we can start moving on to the plots. You can actually use even pandas for visualization. Sometimes you don't have to use matplotlib or other libraries as we define here. This one is mainly like for the analysis, but these three, matplotlib, seaborn, and plotly are mainly for visualization. So here we're saying here geopolitical zone. If we say plot, we have some data here, votes by the political zone that we define above here. Yeah. So here I'm just getting that variable and then saying the plot, so you can see the visualization using pandas. So this is just showing the votes by geopolitical zones. And so let's say we want, and actually there's one thing with this, you don't actually have to memorize all these keywords and stuff. Maybe we have something here saying that plot by chart depicting the number of votes by states. Assuming you don't actually know how to do this, or maybe you can't remember. I'm just opening my browser and I'm saying how to plot a bar chart in Python. Yeah, I'm just searching, and I can see the first link here, and I'm going here trying to search. So if you come here, you can see there's something here actually showing bar chart. So if you copy this code, you come here and you say you paste it. But you know that this code is doing something else, and we don't want to do something else. We want to visualize the bar chart based on our data. But this code is using this data, right? So we remove this part of creating data set because we don't want to create a data set. So we can put our X and Y values here. So let's say we want to say, we want to put, let's say, something like the number of states here, the states here. So we can say something like states equals, we go to our data frame and then access states. So we have states here, and then we say values is equals to we go to our data frame again, and now the values will be what? Will be our values for, let's say, the states. The values of, let's say, votes cast. So we can say state instead of like courses, and values is just values. And if you print this, you will get it. But if you look at the x-axis here, it's not visible because there are a lot of different states with different names. So maybe we can access the first 5 ones, the first 5 states, let's say. If we print it, you see we're getting Abia, Adamawa, Akwa Ibom, Anambra, and Bauchi. But the x-axis is still something else. It's showing courses offered. But here we want our x-axis to be state, and we want our y-axis to be votes cast. And maybe the title, number of votes by state, let's say. Number of votes by states. And then let's print it. Let's see, we're getting our bar chart now, showing those things. So here, let's say we want to show, but this is show, let's say, the votes cast. So let's say we want to show APC and PDP votes side by side for these 5 states. Firstly, because here we didn't actually do anything, we just copied the code from somewhere and we searched, and then we copied the code from somewhere. So here, let's say we want to do it by ourselves. So you first define you first define the figure, saying I think we need to first import. Did we import? Yeah, we import matplotlib here. So yeah, we don't need to import again. But yeah, the first step to doing this is first starting the import. So we've imported it already, so we don't need to import it again. So we say plt dot subplot, and then we kind of like give the size. What size do we want? Let's say 12 by 8 or something. And then we identify, like we say, we kind of define, we need to define the width as well. So let's say we want the width to be 0.25. And then now you want to define where you want to place this, place your bars. And there's this function, numpy.arange. So we can get where we want to define our bars. But do we have the data actually? We don't have the data. We do not get the data. So we can use this same data. We didn't define the data that we want to use here. So let's say we're defining this. We're saying we want to use, let's say, data 1 and data 2. And we want to put APC and PDP votes side by side. So we can say something like APC votes, and here will be PDP votes. PDP votes for the first 5 states, yeah. And then our range here, we get the length of the first data, and then we define the second one as well. And the second one, we kind of need to define it based on the first one, because we don't want to put them on the same, on top of each other. We want to put them side by side. So we can say something like x plus bar width for x in bar 1. So this is kind of like considering this width that we defined here, and then putting the next bar beside the one that we've already put. Let's say if we put APC first, then the PDP one will come, will be placed next to the APC bar. So here we want to now put our bus. We're saying bar 1, and then we're saying data 1. We're giving the XY. So which color do we want to use? Let's say we want to use red. You just say R, and then that will be considered as your color. And you need to define the width, which we already did above. So we say bar width, yeah. And then if you want, you can define things like age color or something like that. Let's say we want the label of this to be APC vote, because the first one here, data 1, we say APC vote. Let's say we can also add the age color, something like gray. So we can just copy this and we add it here, and we change the second one to data 2. So this will show the PDF one, yeah? And then we're saying green. Other things will be the same. The label, but the label will be PDP vote here. And we can try running this to see if we have any error actually. Yep, we have an error. That's fixed size, which is called fixed size, not fixed size. Yeah. So you see, it's kind of like defined this way, but it's not complete. So it's kind of it did put one on top of another. So we can customize the width here. So if you want to customize the width, we say X thing. And then we say our R plus, let's say bar width. So we're shifting it here, bar width. And then we say go out and change length of data 1. Yeah. Yeah. So we have this. We can try. We can it this way. Still not yet. So what do we have? Again, we can define. Let's first define everything. We can say the first X will be IBR. Then we have Adamawa, and then we have Accra Ibom, and then Anambra and Bauchi. But still, this is actually PLT.show. Usually, in some editors, like you won't actually see this until you put something like PLT.show. This will be the thing that will show you your graph. But there is something wrong with this. What is wrong with it? For X and bar, we put bar 1. Because we say bar 1 for all of them. One of them should be bar 2, yeah? And then we define, you see, now they're placed beside each other. But if you look at this now, this the x-axis is like placed on the second bar, but we don't want it to be placed on the second bar. Maybe we want it to be on the middle. So sometimes this is kind of like, you know, something like trial and error. Really, it's like more of an art than programming, because you just need to play with the number sometimes and then try to get it before you'll be able to get it right. So let's say what's in point multiplied by 0.05, and you see now it's like placed at the middle. But then we don't actually know. Now, if I ask you, for example, what this represents. Maybe you might tell me that, okay, one of them is APCM, one of them is PDP votes, but then if you send this to someone that didn't actually see what we're doing here, then they will not be able to identify which one is APCM, which one is PDP votes. Actually, even for us might be difficult, but then just because we say bar one is APC, bar two is PDP, so we can say the first one is APC, second one is PDP. But we need to kind of like make it clear such that even if someone that isn't here will look at it, then they'll be able to understand. So we can put the legend, and if you look at it, you see APC and the PDP vote, PDP vote. So this legend can also have like we can change the location, can have some parameters. Let's say we want to put it upper left, and then let's say we want to add title called party. Title equals party. So you see, now we put it in upper left and the title is equals party. And let's say we want, because here also you can see we have Adamawa and then like some numbers here, but we don't actually know what it is. So we want to define the X label, plt.x label, and then we define the X label, we call it states, and then we say the font weight, let's say bold or something like that. Then maybe font size, and then we're saying 15. So now we define the X label, and you see we have states here. Similarly, we can just copy this, and then instead of X label, we just say Y label, and here we say number of votes. So we should see something in the Y-axis, number of votes, yeah, which we did. Nice. Okay, so yeah, there are some other plots I feel, but maybe I'll just jump this one because of time, and then because there's something that I really want to show. So we have the calculate sum of votes cast group by geopolitical zones. Maybe we can do this one. So if we're to calculate the sum of votes cast by geopolitical zones, here we can say something like we're calculating. Again, apologies for my use of variable. Like I'm just defining this variables. Like anyhow, so votes cast, and we're saying group by. What are we grouping them by? Geopolitical zones, because we want to kind of like consider geopolitical zones, nice. And then we just say sum, yeah. And we need to say, because we just group it, and then we say pi data equals, now we need to say pi data dot values. We just want to get data values. Pi data dot values, and then yeah, we have the values here, and we also want to define the label. So we can say pi label equals df, and then we get geopolitical zones. Yeah, we did this above actually dot unique. So this is getting the unique geopolitical zones. We can say pi label, and then there's something with this. If now we print, it will only print, if we run this, it will only print the labels, but it won't print the pi data because we did not put it below. So if we say, but if we say something like print this, and then maybe print this, this will print both of them. but that is not what we want to print, so we can just comment both of them here. So to plot our bar chart, we can introduce Seaborn here. We've already imported matplotlib above, but we didn't import Seaborn. Maybe we will use it later, but yeah, we can say plt dot pi, and this is also using matplotlib, and we can say pi data, and then labels equals pi labels, yeah, and maybe just plt dot show pi label plt dot show. So now we should see, is it pi label? Yeah. Now we should see some pie chart with showing different regions. But let's say we want to see the percentage here. So we should add something called autopacity because 0.0. We want to see the percentage in 1 decimal point. Well, I mean, it won't really show anything, I think, but it won't show the decimal point. Did it? Yeah, it did. But we should have this percentage here also, this round. Yeah, okay, so we have the percentage here. So now we did introduce Seaborn, but we did not use it. So let's say we want to use this Seaborn. Seaborn, you can use Seaborn to kind of like make your plots beautiful, just for them to look maybe nice or something like that. We are just changing the color. We're saying palette color, we've defined this as black. Now if you say colors, because palette color, this is then bright, yeah, so it will show. I think we've already like the default is bright, so that's why it's not changing. But now let's say we want to make it dark. So you see, this is now dark, but we can leave it as bright. But we can say we can also do dark. Now we copy everything here. The same thing we have above. What are we doing? We're saying plot pie chart depicting the distribution of votes by geographical zones. It's the same thing above, but then using splot. And I will show you what splot is doing. Sometimes you might want to highlight certain areas in your graph or something. Let's say you just want to highlight, let's say the Northeast. You want to say something about the Northeast in your presentation also. So you can have something like 0, because we have 6 geopolitical zones here. I don't know, is it 6? 1, 2, 3. We have 7. Okay, so we have 6 here. So, but which one is not this? What now we want to highlight it? We can say there's this parameter we can add here. We can say exploit equals exploit. Because exploit, yeah. But we want to highlight one part of this. Let's say 0.1. I don't know which one is it. Not is here, but we can check. So it's highlighting the Southeast, for example, now here. 0.1. If we use it for the second one, yeah, that's Northeast. So yeah, we have the Northeast. So let's say you want to highlight something in your presentation, you can just use exploit and then to show how this is working. We don't actually have a lot here, but I don't know if maybe I can quickly go through them. So yeah, now here we have plot a volume plot depicting the distribution of votes by geographical zones. So we want to use a Boolean plot. We can define something, PLT.fix size. And from this Boolean plot, actually, you will see, we will just copy and paste the exact thing, and then just change the name. So sometimes the thing here is really like to understand how this thing works, and you can play with the plot as you like. I know it's seeing some error. Click size, maybe because yeah. So the same Berlin plot. Usually, you can have this type of thing when you want to have like two plots side by side, but then here we only just want to use one because of time, and it's using Seaborn actually. So maybe we can say this Seaborn that we're importing. Maybe we can just import it again, but I don't want to be writing Seaborn all the time, so I can just simply like import Seaborn as SNS. So this is the short form of Seaborn. Just like pandas, we write in like we write in PD for pandas. So Seaborn we're writing SNS, and then we're saying violin plot, and then we send our X. Actually, we should first get our data before that. Before then, our data is equals to df, and then we have the levels. Let's say we want to show the broadcast. So here you can say our data X is like geopolitical zone, yeah. And then Y will be our label, which is the broadcast, yeah. And then our data will be our data. That's the data frame. So we're accessing our data frame. So labels, change one of them to label or labels. So yeah, now we have the same thing. So when you say this, X figured add subplot. What is the error? Is saying figure object has no attribute subplot. Did we say plt.figure, and then we say fixed size equals 25. Let me just say dmat plot. Okay. As plt x1 is equals to fig.add subplot. Well, okay, we can just comment this for now and see. We did not define that, but it did work. Good. Okay. Yeah, we define it here. So yeah, this is like using volume plot. So, but then you can see this is not really customized. So we can customize this maybe if we want, we can say like we can customize the label for label in X1 that we get the X sticks, get maybe X levels, and then this is kind of suggesting sometimes when I start writing, then it will suggest it kind of predict what I'm trying to write, and then it will just suggest the remaining thing, which is quite nice because sometimes you kind of forget what you want to write, or yeah, I mean, you can't really remember everything all the time. So That's why it's good that it's suggesting. So we are changing the font to sans serif, and then we're saying the we want to change the weight also. Maybe font weight. Let's say we call it bold. So you see the text level is now changed. It's bold, and then we kind of increase the size. Similarly, you can do the similar thing for the y-axis. We can copy the same thing, but here, let's say we want to do something different. So we can say that should be y also, yeah, because it is for the y-axis. And we can say something like label dot set visible. Maybe false. So we don't want to see the y-axis, for example, if you say false here, should be turned up. It's not up. Something is wrong. Anyway, it should be off. Or when we set this to kind of false, it should be off, and when we set it to true, it should be set to true. But it did not work for some reason. I don't know why. The X1 did get Y ticket levels. If let's say we just comment this. Okay. The first one works, but the second one doesn't work. And maybe if we finish the thing, then it might go at the end. Okay, so we're saying PLT here, we can just define the Y label, and then we can come back to that later. But first, we can actually customize this by using something like importing some fonts, kind of like defining our own custom font, saying something like CS font is equals to font name. We define the font name, and then we call font text. Yeah, and then each font, we define another one. We call it, let's say, font name. Font name, we call it here, let's see. Yeah, and then we can say something like CS font weight, and then we have alt for Y label. We're just customizing this, and then we can say geopolitical zone. I think we are almost. Yeah, so still we can customize this based on adding different stuff. And once you have this, actually, these ones will be really easy. You can just copy paste. We're saying what? Bar plot. Instead of saying by employee, you say bar plot. And then you just say run. You run your program, and then you get the same thing. But then here you get bar plot. And yeah, actually here we say box plot, so we can say box plot here, and then here this is bar plot, and then bar plot. Bar plot and then histogram plot. I know I heard some sound. Someone said something. Like, probably not. So this will be like histogram plot. That will be like hist plot. Yeah. So it depends on really what message you want to convey sometimes, because you see all of these are giving you something, are showing you something. So let's say box plot, we run this. All of these are showing you something. But the important thing here, I think, is the method that you want to convey. So, for example, this box plot is showing, as you can see, and the south region, let's say, the state with the lowest number of podcasts is around maybe 500,000, and the highest number of podcasts is around 1 million. And Northwest, let's say, the highest number of votes is like almost 2 million, and then the average is around 1 million, but the lowest number is around 800 or so. So you can see different things, and this bar plot is showing you like the standard deviation, kind of like the changes across different states, different geopolitical zones. But the histogram is showing something. I don't know what this means, but yeah, it's a bit maybe hard to interpret. So it depends on the message that you want to convey. I think you can just play with this, and then yeah, that's it. And so maybe I can just show this. I really want to show like one plot from Plotly, but I can show this, then maybe show that one afterward as PX. This will be really easy. But that one I'll probably not try everything, because I think I did it sometimes. Maybe I'll just copy it and then I'll just explain. Here we're saying X and then geopolitical. The difference between all of these things, or the things that I've shown so far, and Plotly is like, Plotly is interactive. It provides interactive and interactive visualization. So you see, those ones are just like, I mean, they're just providing different visualization, but then they are not really interactive. You can see them, but you probably can't interact or play with them. But here you see, as I put my my mouse on this, like just hovering through it, I'm getting like the breakdown of the podcast and stuff like that here. And maybe I shouldn't show the rest, but there is this thing that I really want to show, which is like using kind of like photo plate. So earlier today, I was just trying to find a way to visualize this, and then I found something. There's something called photo plates, kind of like visualizing on the map. I mean, on like the map of the country. So I tried finding the map of Nigeria, but then usually the normal way of doing this is like you just search online or like download shared file, maybe download shared file, maybe Nigeria. You'll say like Nigeria shared file or something like that. So when you click on this, let's say you go through it and then you find the shape file. And after finding the shape file, you will need to kind of go to a website called MapShaper. MapShaper. And from the MapShaper, you just put your shape file here, and then you get some easy, or like kind of like you get a shape file that can be used in Python. But I tried getting that, I couldn't. But then luckily I found some JSON file which does kind of similar. So it's from GitHub. So this is the what the JSON file is doing. As you can see here, we have like the map of Nigeria, and then with different states. So I'll just copy this because I have written it somewhere and I will not write it again. So I just paste it here. So this is also using Plotly, and then it's reading our JSON file, which is Nigeria regions.json. And then here we are kind of like reading that file, and then we're merging the data from JSON with our data frame, with the election data. So left join will have ID, and then right join will have state. So the left join is the first table that comes first, which is the JSON file, and then we have the data that we just finished using right now, and that is called what? That is called like I mean, that one has ID as the state. Yeah. So if you look at those two data, I mean, if you look at that, so if not look at the data actually, if you just say print this, if we print this, we should see a map of Nigeria. I mean, so this is like a map of the world, but then there should be Nigeria somewhere. Nigeria is here in Africa. And we zoom through the data. We come here. You see, it's showing Nigeria and different states. And then, but this is showing PDP votes. Maybe we want to show the number of PDP votes and APC votes. Anyway, so this is showing PDP votes. And if you look at this, there's some place that's blank. So if we are to say which place is blank, we go to Google Map. Seems like Abuja, yeah? So Abuja is blank, but why is Abuja blank? So one thing we can do is like we can check the data. If we check the data, then we will understand, because it's not really easy. Sometimes it's hard to kind of just predict what happens without visualizing the data. So we're visualizing, and then we can say Abuja is written as Federal Capital Territory here in the data. But in our data, if we say DF, we look at state, and then you print that, you see Abuja is written as FCT. So it's not finding the join. So they are not matching. The two of them are not matching. That's why it's not finding Abuja. So what can we do here? We can just maybe change Abuja in our data to be Abuja instead. Maybe we can say df.log. Actually, we are changing Abuja now. We're trying to make Abuja to be what? To be Federal Capital Territory instead of FCT. We're saying if you see FCT in this data, then you should say change the state to Federal Capital Territory. We have it down here. You should change it to Federal Capital Territory. Yeah, seems like it worked, but let's see. There's still some space, but it's Abuja there. That's the most important thing. Yeah, oh, now we can see Abuja here, yeah? But there's still some space. But I think ideally Abuja should cover this area, but this is due to the shapefile. And but yeah, this is due to the shapefile, and you can change this by maybe using a different kind of like how do you call this? Like there are different things in geospatial analysis that you can use to visualize map. So you can change the way the map, I mean the coordinate system, yeah. So you can change the coordinate system to the Nigerian coordinate system. I don't know what is the Nigerian like the coordinate system that Nigeria is using, so probably not, but yeah. Maybe I won't be doing that today, but yeah. So now here, this is showing PDP, only PDP votes, but we want to show APC PDP votes. So here, I would like to show you one thing. So let's say we will use ChatGPT. We'll just ask ChatGPT to do this for us. So we have our code, yeah? We already have our code. So we just copy our code. And now we want to ask ChatGPT. So we're saying, will you modify this Python code so that hovering over elements will display maybe the distribution of both APC and PDP. APC and PDP votes. And then we put our code. So we ask ChatGPT to do this for us. Hopefully, it won't disappoint. So it did something. Now we copy in and then we paste in this here. But if you look at it, it did define some data frame, but we don't want it to define data frame for us because we already have our data frame. So don't define data for us. And this left join should be idea, and this is states. Yeah, so let's run this. It looks like it worked, but yeah, let's zoom this and see. Now, if we hover over any state, we are expecting to see the distribution of votes, both APC and PDP votes. So you see APC votes, whatever, Borno, PDP, yeah, it did work. So yeah, that's nice. Another thing you can do with ChatGPT, really, like you can really do a lot of things. Let's say here we can just ask ChatGPT. We have the data, yeah? So we copy everything, Control A, Control C, and then we coming back. We're saying, I have this data set, and then I paste everything, right? Now I'm saying, suggest 3 different plots using Plotly, because we didn't get to do the Plotly analysis a lot. So we're just asking ChatGPT to suggest 3 different plots to analyze the data. Plus to analyze the data, maybe. So just 3 different plots to analyze the data, maybe using Plotly library also. So yeah, we're waiting for ChatGPT's response. Seems like suggesting something. Yeah. So yeah, let's first copy the first one. It looks like that's a bar plot. So if we copy that, here we just put it here. We already have our data. We don't want to read our data again. But I think we call it DF. So we just say here. You see, that works. So Now we go again, we check the second one, scatter plot, and then we paste it. Again, we have our data. We don't want ChatGPT to read the data again. I mean, this is just reading the data, but we don't want to read the data. Scatter plots, and you can see when you hover over these things, it's showing you like the distribution. Nice, and then the last one, it is pie chart. Okay, you can copy, paste, and then maybe we don't need to import again because we've already imported. Yeah, seems like 50-50. That's not correct. I don't think that it was a PTV box to be 50-50. Then no one will win the election in that case. Yeah. But yeah, anyways, this is just to show you like how this thing is working, and then how you can do something similar, really. Yeah, I think probably over the time I should definitely stop at this point.
Thank you very much, Dr. Harrison, for this wonderful presentation. We have learned a lot, and I think now we understand in this 21st century, we can't do without AI. Whether it is science, whether it is engineering, whether it is arts, whether it is, I mean, everything, every discipline now we have to do with AI. So I think it is a very productive session, and let us give like 10 minutes because the time is really short now. We can allocate 10 minutes if the audience have some questions they want to ask. So please, the floor is open for Q&A. So if you have some questions, please let us hear it. And then Dr. Harris will try and answer it. Yes, Dr. Mubarak.
Hello, thank you. Thank you, Dr. Harris, for this educative session. Please, I would like to know, how do you carry out some like basic statistical analysis like t-test, ANOVA, using Python? How do you do that? If we have time, could you please little bit demonstrate to us how to do that?
Definitely. I think there are different ways to do this, like in Python. But one way, I mentioned that I was going to show this, but then I forgot. But so if I will definitely share this link. I mean, the link to, I have some repositories for kind of like this analysis and stuff that I think will definitely help. And I can show that to you if and only if I can just get this code option. Yeah, maybe this. I'll just try to log into my repository, and then I will show you those things. Okay. I'll probably share this with everyone. I mean, I'll just maybe put add the repository here, but yeah. So you can with these repositories you can see how we can do a lot of different analysis. So you mentioned like ANOVA, right? Did you say ANOVA or something?
Yeah, t-test or ANOVA.
Yeah. So yeah, for example, you see ANOVA. Let's say we have some data here. We are grouping our data, say like marks, on marks, question marks. This is like for a data set I worked on for kind of categorizing emotion from people's faces with different coverings. And there are 4 types of coverings in that data set. Like one is unmasked, one is masked, and then sunglasses. Unmasked is basically without mask. So the key thing is like this is actually just doing like kind of analysis and stuff. Just understanding the data. But what you're actually doing is this. This model OLS. This is finding you're using the OLS from this directory stats model formula, and that is linear. Is it OLS is like this linear regression or something like that. So you're performing that. You're saying based on the performance, you're giving some levels, and let's say you have those 4 different groups, and then you're fitting it to your model. So Python is actually doing everything for you here. But after you get the result, so we have ANOVA, like SM, the stats ANOVA LM. So this is the thing that is actually doing ANOVA for you here. So this is type 1 ANOVA. If you say type 1, if you say type 2, and if you say type 3, you can change this like from the parameters. You can just change your stuff. So it depends on the thing, like for type 1 ANOVA, type 2 ANOVA, maybe you have to perform between the 2 or more groups or something like that. And then depending on the group and your kind of analysis, the thing that you will be using will definitely change. And if you want to have a table showing everything, like kind of like a visualization of the F statistics, eta square, the p-value and stuff, you can use something like this formula, and then you get your value here. And I'll be happy to share this with you actually, or maybe with I'll just put the code that of everything we did here, and maybe we just put a link to this repository where people can access this. And this is coherence stats. So yeah, you can find coherence effect as well using this. And I think I have t-test somewhere as well. Yeah, but it's just using these functions. Really, you can do everything with in Python, like using this stats model function. And yeah, yes. One thing is that I want to show you something, but I think I have that somewhere as well. Anyways, we can find those things here. Yeah, there are just a lot of different things right now. But this I just do it to do the 2 of them. But there are other things that you can do using the stats model. We can also search, let's say, the t-test, for example, t-test Python. I know it's using the stats model. We have the first group and second group, but the limitation with t-test is that you can only test 2 different groups, so you can't test like more than 2 groups. So assuming you have something here, you have your first value. This is just like they're just one such way, really. Like you just have your first value, let's say R1, R2, and then start the t-test. So this is just from the stats model as well. Scipy the stats, and then you just say stats model. I can show you one maybe here with the total number of votes. Let's say, I think we have something called APC votes. Did we find something like that? Yeah, so we have APC votes, and then is it a list? APC votes list, let's say is equals to BF, and then we are saying APC votes, and then now we want to find PDP votes. List is equals to BF, and then we say PDP votes. So we have two lists now. So we can find the stats for these two stuff. If we just go back to our repository and then import this SciPy stats, and we define it here. Yeah. And then so we're saying stats, TTS, whatever, and then we're saying APC votes list and then PDP votes list. So we're finding this the difference now between APC and PDP votes, but we're using t-test because we have two different groups. Yeah. So if we say something like print, now we want to print our result. So you see, it's showing the statistics here. This is the p-value. Well, not significant, yeah. So maybe if and only statistics applies and all this, and then maybe you will say APC did not win or something like that, because the p-value is not significant, like 0.07, unless you're considering 0.1 in this case. Otherwise, then it's not significant. But yeah, so yeah, this is just like what you can do. You can do this thing.
Thank you very much, Harisu. I think because of the time, maybe we can take one more question if we have a question from someone. One more so that we can round up because of time. I know it is due to the time difference in New Zealand for Dr. Harisu. I think it is getting to, I think 1 a.m. now, right?
Almost 11, I think. 11.
Almost 1 a.m. So I think it will be just from our side that we conclude and free Dr. Harisu to have some sleep for tomorrow, because tomorrow is Monday. So if there is any question, please, one more question, please. So I think in the absence of any question, Dr. Harisu, thank you very much for this wonderful presentation. And I hope this is just the beginning, and it just ignites our thirst so that we can learn more and more about these AI tools, so that we can explore and use it in our various endeavors and improve our capacity. Thank you very much, Dr. Harisu, and thank you all, the audience. We will see you again next time for another version of this in-house seminar regarding the capacity building. Thank you very much. Thank you all.
Thank you. Bye.